എഞ്ചിനീയറിംഗ് മെക്കാനിക്സിലെ കുറച്ച് പ്രോബ്ലം ഒന്ന് നോക്കാം. എഞ്ചിനീയറിംഗ് മെക്കാനിക്സിൻ്റെ കുറച്ച് ക്വസ്റ്റ്യൻസ് ആണ് നമ്മൾ ഡിസ്കസ് ചെയ്യാൻ പോകുന്നത്. അപ്പോൾ ഒരു സിമ്പിളായ ഒരു പ്രോബ്ലം നോക്കാം. ആദ്യം തന്നെ ഇൻ എ റെഗുലർ ഹെക്സഗൺ ABCDEF the forces 4 F1 F2 9 and 8 kN act along AB CA AD AE and FA respectively and the point A is in equilibrium. Determine the values of F1 and F2. If already in the question it is given it as a point A is in equilibrium, so conditions of equilibrium are applicable at A, that is f of x is equal to 0, that is horizontal components are equal to 0 and vertical components is equal to 0. ഇനി ഫോഴ്സസ് ഇവിടെ നമുക്ക് ഓൾറെഡി 5 ഫോഴ്സസ് ആണ് ഗിവൺ, 5 ഫോഴ്സസ് ഉണ്ട്. സോ അതിൽ 2 അൺനോൺസ് ആണ്. F1 ആൻഡ് F2ൻ്റെ വാല്യൂസ് ആണ് ഡിറ്റർമൈൻ ചെയ്യേണ്ടത്. അപ്പോൾ ഫോഴ്സസ് ഇൻക്ലൈൻഡ് ആണെങ്കിൽ ആ ഫോഴ്സസിനെ നമുക്ക് രണ്ടായിട്ട് റിസോൾവ് ചെയ്യാം, രണ്ട് ഡയറക്ഷനിലേക്ക്, ഹൊറിസോണ്ടൽ കമ്പോണൻ്റ് ആയിട്ടും വെർട്ടിക്കൽ കമ്പോണൻ്റ് ആയിട്ടും റിസോൾവ് ചെയ്യാൻ പറ്റും. അപ്പോൾ ഇവിടെ 4 kN എന്ന് പറയുന്ന ആദ്യം കൊടുത്തേക്കുന്ന ഫോഴ്സ് 4 kN എന്ന് പറയുന്നത് ട്രൂലി ഹൊറിസോണ്ടൽ ആണ്. അപ്പോൾ അതിന് റിസോൾവ് ചെയ്യേണ്ട ആവശ്യമില്ല. സോ അതിന് വെർട്ടിക്കൽ കമ്പോണൻ്റ് ഇല്ല, അത് ഹൊറിസോണ്ടൽ കമ്പോണൻ്റ് മാത്രമേ ഉള്ളൂ. ഇനി 9 kN എന്നൊരു അടുത്ത ഫോഴ്സ്, അത് ട്രൂലി 90 ഡിഗ്രി, അത് വെർട്ടിക്കൽ, അത് y ആക്സിസിലാണ് കിടക്കുന്നത്. സോ നോ നീഡ് ടു റിസോൾവ് 9 kN ഓൾസോ. But F1, F2 and 8 kN, those three forces are inclined forces. So we need to resolve these forces in horizontal and vertical component. In F1 force, direction is also important. Before we going for the resolution of forces, sign convention, we need to study about the sign convention of forces. If the force acting in the rightward direction, that is taken as positive. And if it is leftward direction, negative. Upward it is positive. Downward it is negative. So first horizontal components, first one is 4 kN, that is in the rightward direction. So we can take it as positive 4. Next force is F1. F1 with the angle, with the horizontal angle is 30 degree. So two components is there. First is F1 horizontal component. Horizontal component of F1 is like this. F1 arrow leftward, F1 cos 30, and its vertical component is downward, arrow is downwards, and it is F1 sin 30. F1 sin 30. So for F1, if you resolve the forces F1 in horizontal and vertical component, horizontal component is F1 cos 30 and vertical component is F1 sin 30, and arrow also, direction is also important. So here the horizontal component is F1 cos 30 and it is acting in the leftward direction, so it's negative, minus F1 cos 30. Next one is F2. F2, if we resolve the forces, resolve F2 in two component, horizontal and vertical, F2. So the entire angle is 60 degree. This is F2 cos 60 and the vertical component is F2 sin 60. So we are here we need to take the horizontal component, that is rightward direction, so it's positive and is F2 cos 60. Then the remaining one is 9 kN. 9 kN is in the vertical plane, so no need, there is no horizontal component for 9 kN. Next is 8 kN. 8 kN, two component, here 60 degrees given, so this is a horizontal component, 8 cos 60, and the vertical component is downward direction, 8 sin 60. So horizontal component is right side, positive 8 cos 60. So we can from this rearrange, that's equal to 0. F1 cos 30 plus F2 cos 60 is equal to minus 8 cos 60 minus 4. First equation. Second, resolve the forces in vertical direction. vertical direction forces are 4 kilonewton, there is no component. Only that force entirely in the horizontal plane. So no, if the force in inclined only, there is a vertical component is there. And for F1, the component is it is downward direction. So again minus F1 sine 30. Then F2, the component is upward direction. Sine 30 upward direction, angle 60. So plus F2 sine 60. Next is 9 kilonewton is in the y direction, so positive 9. Next is one more component is 8 kilonewton, that is downward direction, 8 sine 60, that's equal to 0. So rearrange the values, F1 sine 30 plus F2 sine 60 is equal to 8 sine 60 minus 9, second equation. So from the first equation, we can get the F2 value as minus 16 plus 1.73 F1. That is our third equation. Then substitute the third equation in second equation. So from this we can rearrange and get the value for F1 and substitute F1 value in in 3. F1 in 3. We can get the F2 value as 4.42 kilonewton. Second question. ABCD is weightless rod under the action of 4 forces P, Q, S and T as shown in figure. If P is equal to 10 Newton, Q is equal to 4 Newton, S is equal to 8 Newton and T is equal to 12 Newton, calculate the resultant in magnitude and direction. Also locate its point of application with respect to the end A of the rod. So all the values are given. P is 10, Q4, S8, T12 Newton. Then we need to calculate the resultant. The 4 forces are inclined forces. Inclinations also given. So for calculating the resultant, first we need to resolve the forces in horizontal components and vertical components. Then substitute the result. R is equal to root of f of x square plus f of y square. So first we need to resolve the forces. So first for easier, forces Fx and Fy. First force is P equal to 10 Newton. Its horizontal component is like this. It is in the leftward direction. So negative 10 cos 45. And vertical component is positive sine 45. Next is Q, that's equal to 4 Newton and inclination is leftward. This is 4 cos 30 and this is 4 sine 30. So leftward, so negative 4 cos 30, downward again negative 4 sine 30. Next is 8 Newton. 8 Newton this is 8 cos 30, 8 sine 30. So positive 8 cos 30, 8 minus 8 sine 30. Last one 12 Newton. Components, this is T, 12 cos 60, 12 sine 60. So already we resolved the components in horizontal and vertical direction. Next we have to calculate the resultant. For that we need to take the algebraic sum of f of x. F of x value we will get it as 2.39 kilonewton. Is it kilo? 2.39 and f of y value is equal to 11.46. 11.46. So next R, resultant is equal to sum of horizontal component square plus sum of vertical component square. Substitute these values and we will get it as 11.71 kilonewton. Next, first we get this is the magnitude of the resultant. To calculate the inclination, that is theta, tan inverse modulus of sum of f of y divided by sum of f of x, that's equal to tan inverse f of y value is 11.46 by 2.39, it's equal to 78.121 degrees. So magnitude and inclination is there. Next we need to calculate the position. To calculate the position, we can apply the Variance Theorem or the principle of moments. Principle of moment is nothing but moment of the resultant about any axis is equal to the algebraic sum of the moment of its components. So first with respect to A, if we take the moments, first there is a P. With respect to A, if the force is the line of action is passing through A, there is no moment for that force with respect to A. So first P, there is no moment. Then in the Q, there is two components is there. First component, the horizontal component is again line of action is passing through A. So horizontal component there is no moment. But in the vertical component moment is there. The vertical component of Q is, I can write it as 4 sine 30, that is in the downward sine 30. With respect to A, the direction, the distance is 1 meter, and you can again classify. Clockwise it is negative, anti-clockwise it is positive, sign convention. So this one is clockwise, so negative. Next force is for the vertical component of S, that is 8. Vertical component is 8 sine 30. The distance is 2, and if the direction is anti-clockwise, so it's negative. And the last one is 12. Last force is T, that is 12, and the again horizontal component there is no moment. The vertical component is 12 sine 60, it's upward direction, and the distance is 3. It is anti-clockwise, so it's positive. So we got the answer as 21.17 kilonewton meter. So according to the principle of moment, this algebraic sum of the component moment is equal to the resultant moment. Resultant value into x is unknown. So R value is known, that is 21.17 is equal to 11.71 into x. So x we'll get it as 1.8 meter from A. We calculated x from A. So we got the magnitude, inclination and position of the resultant. Next question, a spherical ball of weight 100 Newton is suspended by a string. Find the tension in the string if a horizontal force P is applied to the ball. Determine the angle the string makes with the horizontal and also tension in the string if P is equal to 200 Newton. So question figure തന്നിട്ടില്ല. So നമുക്ക് figure ആദ്യമേ ഒന്ന് വരയ്ക്കാം. Spherical ball, weight 100 Newton ആണ്, suspended by a string ആണ്, so tension ആയിരിക്കും stringil, and there is a horizontal force P is applied to the ball. We need to calculate the the angle of the string makes with the horizontal. So theta are same. So 3 forces are applied, concurrent and coplanar forces. So we can apply the Lami's theorem. By Lami's theorem, before applying Lami's theorem, so this angle is theta. This is 90 degree. If we make a triangle, it's 90, and this angle is again 90 minus theta. So this is 90, this is again 90. So next here P value is given as 200 Newton. So 200 divided by angle between the other two forces, that is 90, 90 plus 90 minus, that is sine of 90 plus 90 minus theta is equal to tension divided by sine 90, that's equal to weight 100 Newton divided by 90 plus theta, sine 90 plus theta. This is sine 180 minus theta. So again namukidine sine 180 minus theta endana, sine theta thaneyana, that is t by sine 90 ന്റെ value 1 ആണ്, then 100, sine 90 plus theta is cos theta. So from this we can calculate the t value as, if we take this 2, t is equal to 40 sine theta is equal to 200, first equation. These two, again t cos theta is equal to 100, second equation. Solving 1 and 2, we can get the value of theta and tension. Solving these two, so second equation by dividing the first equation by second equation, sine theta by cos theta equal to 2. So that is tan theta is equal to 2. So theta is equal to tan inverse 2, that's equal to 63.43 degrees. So substituting the theta value in any one equation, so we can calculate t is equal to 223.56 Newton.